Okay, so now that we've learned how to factor greatest common factors and factor by grouping, we're going to talk about how to factor trinomials. So a trinomial, remember, has three terms. Okay, and I have this modifier up here, a equals 1. So maybe you need to know what a is. So in algebra, in math, in the world, the generic quadratic trinomial we always use the same letters. These are going to come up again this quarter, again next quarter, again for the rest of your time in math. We always talk about the quadratic as ax squared plus bx plus c. So a is the x squared coefficient. So a is the x squared coefficient. Remember, coefficient, the number that multiplies. Also called the leading coefficient. Okay. B is the x coefficient, the one in the middle if you write it in standard form. And C, remember what we call C, the one without the without the variable? I gave it away, didn't I? Sorry. Constant term. Okay. So all of these values, these coefficient values, are going to play a role in how we factor our trinomials. So the first ones we start with are the ones when a equals 1. So when that leading term is 1. Okay, so factoring is, not in, is like unfoiling. Okay, so when we get our answers, kind of like they looked in factor by grouping, we're going to have a couple of sets of parentheses. Now I've written under here F and L and F and L. So F for the two first places and L for the two last places. Okay, so what we're doing is we're trying to find how to fill in these four spots so that if we multiplied it back together, we would get the trinomial we started with. Okay, so the book breaks it down in two cases, so I'll do the same. And the cases are one if C is positive and the next one if C is negative. So let's take a look if C is positive. So remember how C comes up. I'm going to scroll down again one more time. So ax squared plus bx plus c, the c comes from the product of the two last terms. Okay? And if c is positive, that means, right, the two numbers in the last position have the same sign. Both positive or both negative. They both have the same sign. Okay. So what we will be looking for is a pair of numbers, pair of factors that multiply to give C and add, because they're going to have the same sign, add to give B. Okay. So here's our first example. X squared plus 9x plus 14. A is 1. C is 14 and it's positive. So we're looking for a pair of factors. We need factors of 14 that add to 9. Okay. Now you could also look for a pair of numbers that would add to give 9 first and see which one of those also multiplies to 14. But there are a whole lot more ways to add to 9 than there are multiplying to 14, right? We can write down an exhaustive list pretty darn quickly for numbers that will multiply to 14, right? So 1 times 14, 2 times 7, and we're done. Okay, so then we would look at this list of the pairs of factors of 14 and choose the one, if there is one, that also adds to 9. Right? Exactly, of course, right? The 2 and the 7 do that. So think about those two parentheses. The two numbers in the first, or the two expressions in the first position, multiply to give you the x squared. So that would be an x and an x. X times x is x squared. the numbers in the second positions multiply to give you 14. So that's the 2 and the 7. And then together, the outer, right, 7x, inner, 2x, right, combined to give the 9x. Okay, so now the signs. We need to get some signs in there. C is positive. That means these are both going to be the same sign. And the sign that they will be is whatever sign B is. So they need to add to give me a positive 9x. So it would be x plus 2 times x plus 7. Okay. Okay, here we go. Let's try one more. X squared, okay, we're going to try more than one more, but one more for right this minute. X squared minus 7x plus 12. So now 12, right, a little bit more difficult because it has more pairs of factors, but it's not impossible to write them all down. So we need all of the pairs of factors of 12. So 1 times 12, 2 times 6, 3 times 4, and that's it. And the 12 is positive, so that means I need the pair that adds to give 7. Okay, so the 3 and the 4. Now, since the 7x is negative, right, it's a negative 7x, you could have thought, and some students are very successful with that, hey, why don't I just write the pair of factors as negative 3 comma negative 4? These two multiply to give positive 12, and they add to give negative 7. Perfectly fine. Absolutely great. I happen to just get that they both have the same sign, and this is the sign that they have, right? That the sign of the b. So x minus 3 times x minus 4. Okay. This only looking at the value of c, only valid when a is 1. In the next section, we'll look at the examples when we have a coefficient in front of the x squared, and that's a different strategy. If the x squared has a 1 coefficient, all we need to look at is the c value. Okay. Go ahead and circle my answer there. All right, so case 2 is if c is negative. So just to, right, c is negative. This is, right, the inequality way that we write c as negative. Okay, so for these, the binomials will have different signs. Why do you think that is? Remember where c comes from. Value of c comes when we multiply, right, the 2 in the last position, and I have to have 1 positive times 1 negative to get a negative value there. Okay, so c negative means we have one of each sign. So then when we look at our pairs of factors, we're going to be subtracting to give b. And again, I've had students who were successful just writing down the factors with the different signs and making it work that way. I use a different strategy, so I'm going to show you that one. So here we go. X squared minus 4x minus 21. So c, right, negative. So now we're going to look for a pair of numbers that multiply to 21 and subtract to give 4. And then we're going to have to mess around with the signs to make sure we have them right. So pairs of factors of 21, 1 and 21, 3 and 7. Okay, that's it. So does one of these pairs subtract to give 4? Indeed. And in fact, if I do 3 minus 7, that would be the negative 4. So if I do positive 3 and negative 7, right, that will work. So when I write my parentheses, x plus 3 times x minus 7. Okay. In reality, what my brain does is I have the 3 and the 7 in there, and then I say, oh, but the 4 is negative, so my bigger number down here has to have the negative sign, so it wins in that tug of war of outer, inner. Right? So I know my first matches, x squared. I know my last matches, that's how I chose my pair, negative 21. So now we're just making sure the outer, inner match up with that middle term. Negative 7x plus 3x is negative 4x, so it matches. So that was the answer, this set of binomials multiplying each other, right? These are the factors of that trinomial. Okay. Pair of factors of 6, 1, 6, 2, 3. Oh, this is a tricky one. Super tricky, right? Because well, both of those get to 5. Yeah, right? But one of them is subtracting to get 5 and the other one adds to get 5. Which one do we want? 6 is negative, so we pick the pair that subtracts to give 1. I'm sorry, subtracts to give 5. Okay, so I have an x and a 6 and an x and a 1. My 5 is positive, so I want the bigger number to be positive, so it wins in the outer inner fight. So positive 6 minus 1. So let's make sure. X squared minus 1x plus 6x plus 5x, and 6 times negative 1, negative 6. Okay. So I've left some extra space down here for you to write any other notes you might have about your strategies and to check. How were we checking our answers? Exactly. We were just foiling or multiplying. Right? When you FOIL, you need to get exactly back where you started in order for the factoring to be correct. Okay, so let's practice. There's a practice page. If you want to try it on your own first, go ahead and pause now. I'm barreling on through. So a squared minus 5a plus 6. Sometimes I just start with the shell that I need to fill in. It helps. The two first positions multiply to give me a squared. Right, so an A and an A. 6 is positive, so they're both going to have the same sign, and they're both going to have a minus. So since 6 is positive, I need the pair of factors of 6 that add to give 5. That's the 2 and the 3. A minus 2 times A minus 3. Pair of factors of 32 that subtract, because it's negative, to give 4. So factors of 32. And you don't always have to write down all of the pairs, right? If you see the pair off the bat, go for it. I think those are all the pairs of factors of 32. And I want to choose the pair that subtracts to give 4. Looks like this guy here. So I have an x and an x, and a 4 and an 8. I need the 8 to win. Right, I need the 8 to be positive because it's the bigger number, and the positives have to win because my 4x is positive. So plus 8 minus 4, right? So the different signs mean when I multiply them, I get negative 32. And when I combine outer inner, positive 8x minus 4x. Okay. All right, there's that outer inner, gives me the 4x that was up there. All right. Multiply to 45, subtract to give 4. Right, 9 and 5. We'll do that. X and 9, and an X and a 5. Right? The 9 is the bigger, and it needs to win, right? So negative 9, positive 5. What did I do to you guys on number 4? Exactly. Right? It's like, oh, wait. That doesn't have 3 terms. That's not a trinomial. It has 4 terms. What do we do when we have 4 terms? Yep, we factor by grouping. Right? So before the chapter is out, these are all going to be mixed together, and you'll have to decide. Right? That's kind of the 50% of what the chapter is you deciding the best strategy. Okay? Depending on what it is that you're factoring, what it looks like. Okay, so 4 terms grouping. So x squared leaves behind an x and a plus 5. So when I look at my second group, I really want to leave behind an x plus 5, so we'll factor out minus 2, x plus 5 in parentheses. So we have the same x plus 5, so we have a common factor. Awesome. Go ahead and bring that guy out. And the second set gets, right, the common factors that you took out. X squared minus 2. Okay, 2 more examples. 3x squared minus 6x minus 24. Okay, so here's another 5.1 question. First thing we should do, and I haven't done it yet because I didn't write any like that, but we should always be looking for a common factor first. So is there a factor that's common to all of these terms? Yes, exactly. So first, we'll take out a 3. And that leaves behind an x squared, a minus 2x, and a minus 8. Okay. Now, we're not necessarily done because what got left behind, right, inside those parentheses is a trinomial, and we now have a strategy for factoring trinomials. So we kind of ignore the 3 out in front for a little bit, and we see if we can factor any farther. Think of it as prime factoring integers that you've done before, right? Maybe you know one pair of factors, but if you're prime factoring, you keep going until you get to the bottom, right, till everybody's prime. Well, it's kind of the same thing here. So 8, right, my constant term, negative. So I need a pair of numbers that multiply to 8, subtract to give 2. So 1 and 8, 2 and 4. 2 and 4 will do that. Okay, so this trinomial is going to factor even further. So I'll have an x and a 2 and an x and a 4. And I want it to be negative 4, so I can end with a negative 2x up here, and a positive 2. They have to have different signs because the 8 is negative. And then the 3 stays out in front. Okay, oh, I haven't said this before. I've had students in the past ask, there we go, if the order matters. And it really doesn't. You could have 3 times x minus 4 times x plus 2. It's perfectly fine. It doesn't matter at all. Conventionally, we always put a monomial in front if there is one, right? The 3 is a monomial. But after that, it doesn't really matter. Okay, last example. X squared plus 2x plus 1. Okay. So a pair of factors of 1, that add to give 2. So what do we know that multiplies to give 1? It's the only thing I know, right? 1 and 1. So x plus 1, right? The 2x is positive. So I'm kind of at a guess here. Oh, wait, I don't have to guess because I do know. Those two do add to give me, right, 2. 1 plus 1 is 2. Okay. X plus 1 times x plus 1. So I get my x squared. I get a 1x plus another 1x. There's my plus 2x. And then 1 times 1 is 1. Perfect. Is there another way we could write this answer, x plus 1 times x plus 1? We could. I don't care which way you write it, but either one of these is a smiley face answer. Okay, so either one will work. All right.